It's too cold outside, MagFest is over, I've been doing mostly Wizarducks things for God knows how long now, and I've been neglecting this 3D Wizards YouTube video series for like 3 weeks, which makes me sad. But I want to work on this again, so let's start working on this again. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and today we're going to be implementing some Seesaw platforms in 3D Wizard games. So I've mentioned on a couple of occasions a particular bit of level design from the Scourge Challenge in Harry Potter and the Chamber of Secrets for the PC. And don't ask why that particular item has captured my imagination the way that it has, but here's a video of it on screen for those who don't know what I'm talking about. You can drop a block on one end or the other, you can stand on one end or the other, and you can make the Seesaw platform go up and down. I believe there's actually a speedrunning exploit, which allows you to basically bypass this puzzle, but that's neither here nor there. So today, let's do something like this in Wizarducks. So I went and set myself up some various pieces of what I'm going to call the Seesaw. So we've got a left platform, a right platform, and like the actual bar of the Seesaw and the pivot. The pivot is just really visual. You know what, I'm not sure if I really like where the collision shapes on this are. Let me just adjust these a tiny bit. Right, that's better. So, let me go and export all these to the game files. If I can find my game files, that will be in data files, meshes.dragon. And let's hop into the Game Maker project, and we can start talking about how this is going to be put together. Alright, let's see, I believe last time I was probably working on, like, I don't remember what I was working on. It was probably, like, pressure plates or something. I'm going to want 3D objects. Let's see, I'm going to want... What should I copy? I should probably copy something with a couple different states, right? OBJ 3D. Let's call it OBJ 3D Seesaw. And let's see. I'm going to want a couple states for this to be, I believe... let's call it balanced. I'm just going to remove all the events for now. We can have another state that is tilt left, and let's say that we can have another state that is tilt right. No on spell hit because we're not going to respond to spells. Do I need to cancel a variable definition here? I think I do. No spell response. Let's see. I should probably also write down these, like the names of these 3D objects here, right? So, I don't need target. I'm going to say self.mesh underscore pivot is going to equal something. Mesh underscore seesaw equals something. Mesh block left equals something. Block right equals something. And because I can never remember... Alright, I really should just make, like, the 3D object collection just like some kind of global variable or singleton or something so that I don't have to go through the silliness every time. But, obj game dot meshes dot seesaw pivot seesaw 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 block left seesaw block right. Okay, so I could start, boy, this is a lot. I could start by just let us override this big draw event here. Like, I could just draw all these on top of each other, right? But that's not going to look very good. Block left, block right. This is just going to draw all these things on top of each other. It's not going to look very good. It's not going to really look like anything recognizable as a seesaw because all these are a couple of like 3D objects which have their anchors at the world origin, and I didn't actually instantiate one anywhere. So let's instantiate one somewhere. OBJ 3D Seesaw. Update collision positions. Not that that really is, for the love of God. Okay, fine. Now that the collision positions are really going to be in place at the moment. Okay, so we've just got like a pile of lumber on the floor right now, and that doesn't look very good. You know what? How about if I move that like elsewhere? I think negative 300 on the Z is going to be like some point close to the spawn. All right. So this is one a little bit smaller than I thought it was going to be. I might want to just like double it in size, just like full out double it in size. And two, I'm gonna need to define a few like points of interest or special collision shapes or like anchor points on some of these. So for one. Okay, this is going to be one of those things that's really tedious, and I'm not going to want to waste time on video for. So let me just, one, double it in size, and two, define some anchor points so that we can, like, you know, stick the different pieces of this, the seesaw thing where they belong, alright? Okay, so the pivot, this is like the one thing that isn't going to move on this whole thing, now has a little anchor, known as anchor seesaw at the top, like where that vertex is in the middle, and that is going to. I guess I should probably start with that. That is going to be where this thing is going to exist relative to like the seesaw object itself. And the seesaw now has two little thingies on each of the ends for the left and right arms. That is going to be where the left and right blocks exist relative to the seesaw itself, to the platform, right? So let us re-export all of that. I'm going to need to think a little bit about how this is going to work, because it's been a little while since I've thought about things like this. But for example, the treasure chest is, I believe, doing something similar. So at least in terms of the visuals, not in terms of the collision, because I don't think the lid has any collision shapes. So we're going to take a get the position of each of those points with just a line of code that looks something like this. We can deal with position and translation. All right, I can deal with that, and then set that as our world matrix, and draw the relevant thing. Okay. Let's start by doing that. This is going to be anchor seesaw, right? I did name it that. Okay, assuming I spelled that correctly. The rotation matrix for this, I'm just going to basically build an identity matrix there. I'll get back to the rotation for these things in a bit. And the actual position offset. We know what to do with that, right? This is going to be like base position matrix, right? I don't think I really have to. I don't really think I have to calculate that twice, because that's kind of a waste. That's going to be the seesaw position matrix, and the seesaw transform matrix. Okay. And this is just Feather not realizing that matrix has been set to something. We should be able to, from there, draw the mesh underscore seesaw without any issue. And actually, I'm gonna want, wait. Oh no, because the rotation matrix should be... Alright, we'll get to that in a minute. We should have a platform on top of the pivot now, is the important part. Probably won't have... Okay, so we don't then. Probably won't have... Probably won't have collision in the right place. It's probably... Wait, what am I multiplying? Oh. Variable names. Probably won't have collision in the right place. In fact, I don't think it'll have any collision at all because I'm going to have to manually work that out for myself. But we should have... okay. Neither of the things that I said. We're going to... take the rotation matrix, which is just like an identity matrix, multiply in the XYZ. Maybe if I spell all these words out the proper way, then it'll be easier for me to figure out where we are. The seesaw position, seesaw rotation matrix, which is going to be like probably 30 degrees to the left, 30 degrees to the right, or whatever. Maybe less than that, maybe more like 15 degrees. Get to that in a minute. The seesaw transform itself in like local space relative to the object, that's going to be taking the position and the rotation, multiplying the position into the rotation. Then we're going to take the like the transform of the object itself in world space, multiply that into the seesaw transform. And lastly, on top of that, we're just going to take that and multiply it into the... Wait, do these have to be the other way around? Okay, there we go. So that was all. It just had to be the other way around. All right. Thank you, Exor, for reminding me. Oh no, that's not... Oh no, that is Exor. Okay, Exor and Yellow Afterlife. Thank you, Exor and Yellow Afterlife, for reminding me that I should probably close my email when I'm doing these. Let's see. So this is half of it. Next, we're going to need to take what we did here and do the left and right platform thingies, the blocks as I call them. First, let me close my email. We can next draw the left block. So we can take all this, block, left position. We can have a look at anchor left and anchor right. And that is, of course, going to be in here. Block left rotation matrix. Actually, that's not gonna have any. It's not gonna have a rotation matrix because the blocks on the end are not going to rotate relative to the object. They are just going to... They're gonna stay where they are. I guess I could, while I'm here, also do the same for the right block. But, final position matrix can be the block left transform matrix. Multiply that into the base position matrix. Final transform matrix is going to be taking the object's rotation matrix and multiplying in the final position matrix. We can then draw... block left, like that. that should be one of them. And after this, I think all I'm going to want to really do is, okay, not what I had in mind. I think because instead of... See, I was definitely doing that relative to the pivot, wasn't I? And I'm going to want to do that relative to the seesaw, I think. Like this. We're getting, like, dangerously close to the point where I would probably want to actually, like... that's hilariously wrong. We're getting dangerously close to the point where I would want to use, like, the transform stack. There's a couple functions related to, like, the matrix stack push, matrix stack pop, but I don't know, I feel like this isn't quite complicated enough for me to want to do that yet. Anyway, okay, so this is going to be the matrix of the transform of the left block relative to the seesaw. I guess I can just step through this once more. Black left final position matrix is going to be this multiplied into the seesaw's final. Hang on, wait. You know what? I remembered a function which I feel silly for forgetting about because I end up using it all the time. But the matrix transform vertex function would make this quite a bit less painful, I think. So if I take the matrix of the seesaw, or at least the seesaw's transform in local space, and multiply in block left position.xyz, this will transform it into object space, accounting for any left or right rotation of the seesaw platform. And I feel like that'll make my job a little bit easier. I can probably remove a few lines here. At least for transforming this pivot point in space, you know? And then of course, we can just build an actual matrix, proceed from there without having to do anything bizarre. I feel like that would be a friendlier way of doing this. Probably a little more efficient, too, than just doing a vector matrix operation instead of a couple matrix ones. I don't know if I think that'll give us the same end result as what I had before, though. Alright, yeah. It's in the air a little bit. I feel like the position on the y-axis of the seesaw is being accounted for twice for some reason. Oh, and I think I know why. It probably doesn't actually have to be like a offset like that, but that's just because that's how it is in here, how the model is. Do you not have a bottom? You do not have a bottom. I should probably give you one because that'll be a little bit awkward when we're looking at you from down below. But alright, this is definitely a little bit friendlier though. I should probably use matrix transform vertex when I can get away with it. Let's try the right one. First, I'm going to want to update everywhere where it says left and right. And now we should have the other one. Okay. Do we not? Anchor left, anchor right. I feel like I'm like... Oh. Duh. I was gonna say, I feel like I'm losing something in translation there. Or at least in... some kind of transformation anyway. But yeah, we now have a platform on the left and the right. Now, let's see if this behaves correctly when this thing is tilted one way or the other. Let me just hard code something real quick. If keyboard check, let's say VK. I do like picking on page up and page down. Let's see, if I want to tilt one way, this will be around the z-axis, let's say 15 degrees or negative 15 degrees. If we say page up, we can be tilted that way. If we say page down, we can be tilted the opposite way. And hopefully, if the rest of my math is correct, when I look at this and when I hit page up, okay, we're like 50% of the way there. Something does not have its origin point correct. And something tells me that that's because we're rotating two matrices together in the wrong order. That did not have any meaningful effect. Okay. This is another one I'm gonna have to think about. Okay. Following the rules of matrix multiplication, and it's funny how I sometimes like get this right and I sometimes like don't. But alright, yeah. I was staring at this for way too long before I noticed that these two were in reverse order. So when you multiply two matrices together, the one that you want to add in, add on top of the existing matrix transform comes second. And the base one that you want to start with comes first. I should be able to start uncommenting some of these lines that I commented earlier. We will now have the seesaw on top of the pivot point going left and right. Alright, yeah, that's a lot better. Alright. 15 degrees actually looks about right to me. That was just kind of a guess, because 30 sounded like a lot, 45 definitely sounded like a lot, 45 would put one of the ends below the floor, because angles. But, okay. Everything else is correct. It's just, alright, it was just the seesaw platform that was not working correctly. So we still don't have, words. We still don't have collision. I'm gonna have to do a little bit of work if I want to get collisions. We still don't obviously have it responding to things being dropped on it, because that will also depend on collisions. I might split this into two videos because this is kind of going a while. And this is already very math intensive. So I think I might deal with collision and gameplay next time. First, however, I do want to have it animate, in some sense of the word animate. So I do have an approach function, right? Pretty sure I wrote an approach function. Good. We can say the source is going to be the seesaw angle, the destination and the balance position can be 0 degrees, and the amount can be I'm trying to think, maybe 120 degrees per second.
Hey.
Alright, so delta time versus like player delta time. When we're tilting left, we can approach... Is that gonna... I'll find out. Whether I want that to be positive or negative 15. But anyway, in the update method for each of these things, we can say just set the target angle, and when we build our Seesaw rotation matrix, we can use that angle there. And oh, you know what I don't have? I don't have actually have a way of getting it to tilt left or right, so I'm going to want to do that. As for how this will be triggered in the game, I'll just have the... Okay. That's good. That's working on the first try. I like that. As for how this is triggered in the game, I'll just have probably one of the update or a step event somewhere just checking for collisions on top of the these things. I do have special collision objects, collision shapes on each of these that are just activation zones, much the same way that things like pressure plates do. And then I'll just continuously have the update method check for like when something's standing on it or something, whether that's the player or a block or whatever. In principle, it's pretty simple. The hard part is dealing with all the transforms, right? Anyway, I'm gonna end this off here. Where is this repository? I have too many repositories. Feels like we didn't really get much done today. Next time, I'm going to be finishing this up. I'm going to be making this work with gameplay. I'm going to put all the collision shapes in the correct place and make sure that we can actually like stand on it and that we go up and down and other things go up and down with the seesaw. That might actually be a little bit hard getting blocks to go up and down with it with platforms, because I don't remember if I implemented like moving platforms with blocks, just with things in general or with just the player. But anyway, oh, you know what else I kind of want to do though? Let me run this in debug mode and let me actually profile this and let me see how expensive this one single draw event is. I don't think it'll be too bad, but how do I unlock the mouse cursor? Well, I suppose I'll have to manually disable mouse lock or something, because apparently I didn't have the foresight to have a key to do that or anything. But anyway, what I want to do is run this in debug mode, look at the profile, and let me just run this for like 10 seconds and we can see how much time, where would it be? Let me sort that. The draw event for event performed for Seesaw. Alright, that's pretty cheap. I was a little worried that allocating that many matrices at one time, we've got like probably 10 or 12 matrices being allocated and multiplied in there, which is not a small amount, but like obviously there are ways to optimize that, but it looks like I'm not going to have more than probably a handful of these in any given level. If we have more than 10 of these in a level, I'll be surprised, but I just want to look at that. Yeah, let's close that out. Again, I like that as a commit. And I'm going to end this off here. So, my name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. Look for the 0.39 release. That'll be what we did today. I try to post about 2 game dev videos a week. One, let's make a game like this, and one tutorial. I like to focus on things like the weird 3D things you can do in GameMaker, as you saw here. So if any of that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I hope you all enjoyed that, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.